Shh. How many of you last year in grade 10 did something called Lewis structures or Lewis dot structures? No. Okay, so this is better than my other class. My other class, like only 5 people had done it. So this is good. Shh. So Lewis structures are essentially just simplified versions of the Bohr model. And remember, we're on page 72. But they include only the valence shell electrons. Lewis structures are also Lewis dot structures are known as Lewis structures, Lewis dot diagrams, electron dot diagrams, electron dot structures. You'll see all those names various places. I usually call them Lewis dot structures or Lewis structures. Here is how we turn a Bohr model into a Lewis dot diagram. First thing we do is we take our nucleus, which normally would contain our protons and neutrons, and we replace it with the symbol for that element. Yes? This is nitrogen because it has 7 protons. Yeah? Then what we do, a second thing we do, is we remove the inner electrons. So we leave only the outer shell. Yes? And then we say, why are we bothering drawing all these circles when we could just draw it like this? Yes? And so our Lewis dot structure has 2 here, 1 here, 1 here, 1 here, because nitrogen is in group 15. Therefore, it has how many valence electrons? 5 valence electrons. And the only thing that's a little weird is when we get, no, we'll talk about that later. That's okay. For now, we're going to talk about how we can arrange those 5 electrons. It doesn't matter whether the paired electrons are on the top, or we could put the paired electrons on the side and have the 3 singletons on the other side. We could put the paired electrons here or on the bottom. It just doesn't matter. What you're not allowed to do is to say nitrogen 1, 2, 3, 4, 5. What's wrong with that? You cannot double up until you've filled something in all 4 sides. Okay? So don't pair up until you have to. Right? So if you were drawing this from scratch, you would draw 1, 2, 3, 4, and then your 5th one would go there. Okay? So you go all the way around, and then the 5th one pairs up. Oxygen has 6 electrons in its valence shell. So if we have oxygen, we would go 1, 2, 3, 4, 5, 6. So we have two sets of electrons that are paired up, and we have 2 singletons. So we have 2 essentially holes in that outer shell. Is good? Okay. Now we have to distinguish between electrons in the valence shell as being different from valence electrons. And this only matters for the noble gases. Who are the noble gases? Tell your partner. In fact, if you have a periodic table, why don't you point to them? Radon. Because it's from radiation. Group 18, noble gases. Helium, neon, argon, krypton, and it won't move for me group 18. Okay? Valence electrons are electrons in partially filled valence shells. Valence electrons are electrons in partially filled valence shells. They are electrons that can be involved in bonding. So for every other group, for group 1, you have one valence electron and you have one electron in the valence shell. They mean the same thing. For group 2, you have 2 electrons in the valence shell and you have 2 valence electrons. Same thing. All the way across. Group 13, you have 3 valence electrons. You have 3 electrons in the valence shell. Group 15, you have 5 valence electrons. You have 5 electrons in the valence shell. Same thing. The only place it is different is for the noble gases. Electrons in the valence shell includes electrons in completely filled valence shells. So, noble gases. How many valence electrons? It's full. So is it partially filled? No. Noble gases are completely filled. So how many valence electrons does a noble gas have? 0. Okay. But how many electrons does neon have in its valence shell? 8. How many does argon have in its valence shell? 8. How many does helium have in its valence shell? 2. I know. Okay, so here's the difference is that when you're in group 18, the electrons in the valence shell actually count. And when we're drawing a Lewis dot structure, we draw those electrons, even though we have 0 valence electrons. For helium, we would draw the Lewis structure with 2 electrons. Okay. For neon, we would draw it with 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. We would not draw it with nothing. Okay, does that make sense? Like, I don't want to get you too tied up in this. I'm never going to have you defining electrons in the valence shell versus valence electrons. That's like such weird, silly little semantics. All I need you to know is, yes, draw electrons for noble gases, please, in Lewis structures. Is good? Okay. Okay, so here is neon. You can see it has 8 electrons. Excellent. What you guys are going to do now is, as quick as you can, you are going to draw the Lewis dot diagrams for the first 20 elements. Yeah, I know. It's not going to take you hardly any time at all. There's hydrogen and helium and lithium, beryllium. There's boron, carbon, nitrogen, and oxygen and fluorine too. I don't know. No. That's as far as I get. I don't know.
So he knows that, but he knows that everything, every single thing.
Quick as you can, get them filled in.
Never seen high periodic table, but every time someone new every function.
And one thing I want you to notice is this little section here. Which elements are these? Those are the transition metals. And there are no structures for transition metals. Now, just so you know, that one electron can go at the top, it can go at the side, it can go at the bottom. I don't care. Whatever you want. You can have them all the same, you can have them all different. Doesn't matter. Okay? Nice. Teamwork makes the dream work. Hold on. 1, 2, how many? Okay. It's not such a dream. It will be. How many?
Yeah, I got it. That's 10. Oh yeah, but there's like 12.
Yeah.
That's the toughest photo you've ever taken and ever will take.
Oh no.
How dare you say that?
So we don't do that two person player, we do the 8, 8, right?
Yes. Yes.
Just like one. Just like one of this. Oh, the 4. Like if the last one is like we're doing like 6, we go to do 6. This no, like the very last one was like 3. I know. You can do it.
By the defiance back, reach outward.
I saw your
This is so cool.
Start making
How do you yeah, but like a little over it. How many is that?
So what?
Because the map usually has white feeder.
Oh, just to make one.
Oh,
Oh wait.
Okay, I'm gonna show you one. Okay, for anyone who's having trouble figuring out how many dots, you could, if you wanted to, go to where is it? No. Okay, this is on page, what page is it on? 3.4b. What page is 3.4b on? 3.4b is on page 69, 69. Okay, so beta, this is going to deal with it, okay? Page 69. Shh. So if you look at hydrogen, one electron goes into the first shell, yes? And then when we go across the row to helium, helium has 2 electrons in its first shell, and then the first shell is full, okay? So that means when we start period 2, we need to start shell number 2. We start putting electrons into shell 2. So row 2, lithium has 1, beryllium has 2. We start filling it up. Boron has 1, 2, 3. Carbon has 1, 2, 3, 4. Okay, and we go all the way across 5, 6, 7, and neon has 8 electrons in its outer shell. Now, if we look at the row just below that, if we look at lithium and sodium both have 1 electron, because when we start sodium, we're starting a new shell. Yes, when we start a new row, we start a new shell. Magnesium has 2, just like beryllium has 2. Aluminum has 3. Is this making sense? And then silicon has 4. So you don't have to be thinking about how many electrons it has and which are in the outer shell. You just use the group number 14 to say there's 4 electrons in the outer shell. You use the group number 17 to say there's 7 electrons in the outer shell. So what your stuff should be looking like now so everything in group 2 should look the same. Everything in group 3 should have the same pattern. Boron, aluminum. What's under aluminum? Gallium. 1, 2, 3. 1, 2, 3. 1, 2, 3. Carbon. 1, 2, 3, 4. What's beside aluminum? I can't see any. What is it? Germanium?
Germanium, yeah.
No, beside aluminum is silicon.
Oh, it's aluminum. Oh, I was talking about
Silicon, germanium.
Yeah, there you go.
Okay, 1, 2, 3, 4. We've got phosphorus and then arsenic, I think.
Yeah.
Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and so on and so forth. Whoa, what just happened there? Where did it go? No.
Sorry.
There we are. I would like to know why helium, which has 2 electrons, is different. I would like to know why helium is different from beryllium. Why is helium, why do we have them together, but in beryllium we put the 2 electrons separate? Matthew?
That's the one hotel room.
Yeah. Because helium, its electrons are on the first shell, and there's only 1 hotel room on the first energy level. Yes? So those 2 electrons go together. But when we're doing beryllium, beryllium has its 2 electrons on that first shell, but its second 2 electrons, which are the 2 that we are drawing, and we got 4 rooms, so we won't pair them up yet. Okay? Very good. Is good? Okay. Things that you should know. So this is now on page 74. What do we call group 1? Group 1 is called the alkali. There's a word after alkali. What is it? Metals. Hydrogen is not it because it is not a... Hydrogen is not in the alkali metals because it is not a metal. Okay, hydrogen's like its own little group. It just does its own little thing. Okay. Group 2 is called the alkaline. Now, 1 is smaller than 2. Alkali is smaller than alkaline. Okay, so that's a bigger word because number 1 is a smaller word, alkali. Alkali and then alkaline. But alkaline is bigger in another way as well because it's not just 2 words, it's 3 words. What's the second word? Earth. Metals. Okay, so we got our alkali metals, we got our alkaline earth metals. What are the other 2 groups that we know the names of? The last one is noble gases. Okay, so way over here we have our noble gases. How many people think they know the name to group 17? You don't have to tell me. Okay, I got 1, 2, 3, 4, 5, 6, 7. Anyone want to tell me? Yes? Halogens, yeah, halogens, halogens. Doesn't matter which way you say it. Okay, those are your halogens. You are responsible for knowing those 4 names of those 4 groups. You are also responsible for knowing that the middle pink section, what are those called? Transition metals. Transition metals. And here's the one that everyone forgets. The main group elements. And they forget them because they're not all together on the periodic table. Some of them are on the left side, and some of them are on the right side. Do you see all the yellow ones up there? Every single yellow one is a main group element. Okay, so group 1, all main group elements. Group 2, all main group elements. Group 13, all main group elements. So anything in the main body of the periodic table that is not a transition metal is a main group element. I don't know why you guys don't say things aloud with me, because if you say things out loud, it triggers different neurons than if you only hear it. If you have two different sets of neurons in your brain that are remembering something, you have twice the likelihood of remembering it. If you write it down, you have activated a third set of neurons in your brain to help you remember it. If you do an interpretive dance while you do it, main group elements. Main group elements. They're on one side and the other. Now you have 4 sets of neurons recruited. Plus, it's ridiculous, and we tend to remember things that are ridiculous, which is why I spend so much time singing and dancing up here. Yes? No. They are called other metals. Other metals. Yeah. Okay, so we've got our alkali metals, our alkaline earth metals, we have the transition metals, and then anything that's like under the staircase that's still a metal is called other metals. Okay? So we're not going to worry about what we call them, they're just like other metals. Yes? They are called the main group elements because they are mainly the ones that do things predictably. So the main group elements are all the elements that we can predict exactly how they will bond. And we can also, for the main group elements, draw a Lewis structure. So main group elements, Lewis structure, yes. Transition metals, Lewis structure, no. Okay? So Lewis, yes. Lewis, yes. Lewis, no. Lewis, yes. Lewis, no. Lewis, yes. Is good? Now, yes. Huh? Yes. It only has one possible charge, but it is considered a transition metal. Okay, transition metals are just the ones that are in that, they are in the D block, which means nothing to you. They're in that middle section. Okay? Now, there's another couple of sections that you should know, and those are these guys, which quite frankly, I think these should start with LA, and these ones should start with AC. Look on your periodic table and tell me the name of LA. What is LA? Lanthanum. And guess what the entire row is called that contains lanthanum? It's called the lanthanides. What does AC stand for? No, AM is americium. Actinium. Okay? And what does actinium start? It starts the row that is called the actinides. Yes? So you don't actually have to work very hard to remember the lanthanides and the actinides, because if you look on your periodic table, you will look and you'll be like, oh, it's the lanthanides and the actinides. Yes? Okay. All right. Groups are columns. Did we know that? We knew that, yes? Groups are the columns. All the elements in the same group will have the same pattern of dots. So if we look here, group 1 all has 1. Group 2 all has 2. Group 3 all has 3. Group 4 all has 4. You can draw them in I'm sorry that my dots sometimes become lines. I don't know why that happens. No, it has to do with the fact that there's something wrong with my tablet, but I'm not willing to have my tablet sent in and not have it for like weeks on end. Well, they're gonna fix this one. They're not going to, they'll take it, they'll fix it, and then they'll give it back. But in the meantime, I will have nothing. Okay, we get the general idea. Yeah? Okay. Yay. We're not going to answer all these questions. I'm going to leave that for you to do for homework. What? All of them. So you're going to go, oh, the main group elements are group numbers. Oh, okay. Let's keep going. So we are now on page 77. 77. Favorite element. I'm partial to carbon because it's so useful. Now, if your element has 3 electrons or fewer in its outer shell, so it would look like this, or it would look like this, or it would look like this. Will it tend to gain electrons or will it tend to lose electrons? Gain or lose? How much is full? 8 is full. I have 3. Easier to lose 3 or to gain 5? Lose 3. How if I have 2? Is it easier to gain 6 or lose 2? Lose 2. So if you have 3 or fewer valence electrons, they form ions by losing electrons to gain what they call a closed shell electron configuration, which means that your outer shell is either empty or full. Okay? What? Yeah, empty or full. Okay, so closed shell is empty or full. What types of elements have 3 or fewer valence electrons? All of these guys here, they are all metals. Okay? Metals. Why won't it move? There we go. So these are metals. So metals tend to form ions by losing electrons. If it loses electrons, let's say we lost 2 electrons, what charge would it be? Positive 2. Do you know the name of positive ions? Positive ions are called cations. If you have any trouble remembering that, here is this adorable little cat, and what is he showing you? He's showing you his little paw, and so cations are positive, okay? All right. Now, when we drew Bohr models, let's say we were drawing a Bohr model for sodium, it looked like this. That's Na with a 0 charge. When it lost an electron, it became Na plus. We are going to do a similar process for drawing Lewis structures of ions. Okay? Don't forget, what else did we have to put on here? Brackets and the charge. Okay? So, if we're doing it with a Lewis structure, we take the Lewis structure, which just has that one electron. That electron goes bye-bye. Bye-bye. And we are left with Na with nothing. And then we put brackets around it and we put the charge. Magnesium has 2 electrons. For whatever reason, I put one on the top and one on the bottom. That's fine. These 2 electrons are going to go away. And we are left with Mg 2 plus, and we put brackets and the charge. So when we show that as a Lewis structure, we have the 2 electrons. Each of those go away. And we're left with Mg with nothing around it and a 2 plus. Is good? Okay. I'm going to leave that for you to do for homework. And now we are on page 79. Well, our test isn't until Thursday anymore, so I can give you a little more homework today. Right? Yeah, I'll be light on the homework the next 2 days, okay? What? Yeah, this Friday we have classes. Yep. Okay. Elements, if they have 5 or more electrons, so let's say we had 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. Are these going to gain or lose electrons to become full or empty? These guys are going to gain electrons. What types of elements are these? These are nonmetals. Okay, and we are gaining negative electrons. So let's just say we have 3 electrons that we've gained. That's going to be -3. 2 ways to remember the word anion. You have a negative ion, or anion kind of sounds like onion, and onions make you cry, which is negative. I don't think we need to spend a lot of time on this because you guys have already done naming. How many syllables in the name of an anion? Nitrogen. How many syllables in that? Nitrogen has 3 syllables. What would its anion have? Nitride. 1, 2 syllables. Okay, anions. The names of anions should have only 2 syllables. P3 minus, phosphide, not phosphoride. Just phosphide. Is good? Okay, fluorine becomes fluoride. You'll see we have like a little gap here. right? We fill in that gap. We give it brackets and a charge. Same thing when we have our Lewis structure. There is a gap right here. We fill in that gap. We have brackets and a charge.
So we put fully, then we put the brackets. Because the other one we have no dots on it, and the brackets are fully.
Okay, so this one is full with the brackets. Metals, it's like empty with brackets and a charge.
Actually, it's easy to, if you know like what the charge of it is, because it's always either full or like all empty.
Exactly. It's either full or empty as an ion. Yeah. Okay. And oxygen. Oxygen has 2 holes. So we fill up those holes. Brackets and charge. Is good? Half of you aren't paying attention anyway.
They are what?
I don't know. There's a lot of people talking.
I'm always paying attention, fully invested.
Okay. I think that's it for here. I think the rest of it's just do things. Yeah. Okay. So we are now going to go to page 84. Ionic compounds. Was that?
Yeah, I know this.
What is that?
That is the bond compound.
That is attraction. Yeah. Anyone remember what kind of attraction it is? It's called electrostatic attraction. And that is between a cation and an anion. What do we call that? That electrostatic attraction is called an ionic bond, yes. But there's all sorts of different electrostatic attractions. In fact, every single bond is due to electrostatic attractions. Ionic bonds are because of electrostatic attraction. Covalent bonds are because of electrostatic attraction, just not between ions, right? An ionic bond is the electrostatic attraction between ions. Okay, we don't need to worry about naming because we've already done naming because we're doing unit 3 after 4. What we're going to do is we're going to show the formation of ions from their atoms, okay? So we're going to show the formation of an ionic bond. And what we do is we start with the atoms. We draw the Lewis structures of the atoms. So that starts with A. Atom starts with A. We're going to use arrows to illustrate the transfer of electrons. Arrow starts with A. And then we're going to draw the Lewis structure of the resulting ions. And ion starts with I. So if you can remember AAI, you know how to draw the Lewis structure for an ionic compound. Steps D and E, you don't have to do these because we've already done unit 4. You should be able to write the formula and name of a compound. So these are optional if you want to. Okay? So let's start with sodium and chlorine. Very, very easy. Okay? Sodium. How many valence electrons? Sodium has 1. Chlorine has 1, 2, 3, 4, 5, 6, 7. And you'll notice that chlorine has a little hole here, right? So in order to show, I'm going to get rid of the little hole because it just complicates things. So I have drawn the atoms. That's our first A. What is our second A? Atoms and then arrows. Who is moving? The electron is moving. So this electron is going to move from here to here. So that's our arrow. Okay? And then we're going to write what comes next. It's AAI. I stands for ions. What do we do with sodium? First of all, how many electrons should be on sodium now? 0, because it just gave away its 1 electron, 1 valence electron, right? What do we do to show that it is an ion? We also use brackets and charge. So let's bracket it. And its charge is +1. Yeah, plus. Chloride. Cl. How many electrons now? 8. 1, 2, 3, 4, 5, 6, 7, and now we have 8. We also need to have the brackets and charge. Minus. There we go. I'm going to show you right now what people do wrong. Okay? What's wrong with that? That's not an arrow. That's a line. Okay? It does not show the direction of movement. You want to show where the electron is starting and where it is finishing. So you need to have an arrowhead. Okay? So this would be wrong. I'm going to show you what else people do wrong. Like, where is it going? It's going somewhere to chlorine. Is it going into the gap? Is that electron going into the gap?
Right there.
No. You need to show it going into the gap, right? It should be going right here, but it's going up here somewhere. Is our electron going to end up there? No. So don't draw it going up there. Okay? Don't do that. And the other thing people forget is they forget the brackets, or they forget the charge, or both. Okay? All right. Now, what if we had magnesium? Ooh, magnesium has 2 electrons. This is on our next page now. This is page 85. Isn't it convenient that oxygen has 2 gaps? Yes. Because magnesium, we have now emptied it out, and we have now put those 2 electrons into oxygen, and we have Mg2 plus and O2 minus. Is good? Okay. Now we're going to get tricky. Now we're going to have sodium, which has 1 electron, and oxygen, which has 1, 2, 3, 4, 5, 6. Sodium is going to give one of its electrons to oxygen. Does that satisfy sodium? Is sodium good now? Sodium just got rid of its 1 electron. Is sodium good?
Yeah,
Sodium's good.
Yeah, sodium.
Is oxygen good? No. How could we fix that?
We need more electrons.
We need more electrons, but sodium only has 1. Oh no. Add what? Have another sodium. Oh, that gives us another electron. There we go. So if you don't have enough electrons or if you don't have enough gaps, just add atoms until it all sorts itself out. Now what we are left with is we are left with Na
Oh, yeah.
plus
Okay.
Na. Whoops.
See, that's the mistake you make.
I know. And look at, and I cannot erase it. Why will it not let me erase? There we go. Na plus, and then we have O. Two minus. Okay? It is optional whether you draw out both sodiums or whether you say, I have 2 sodiums. So you can either do this or you can do this. Yes? Either way is good. Magnesium and bromine. We're going to have the same sort of a problem. Here's magnesium. Magnesium has 2 electrons. Bromine has 1 gap. Here comes the electron. Is bromine satisfied? Yes. Bromine is satisfied. Is magnesium satisfied? No. How could we fix that? Add another bromine because that gives us another gap. Right? All right. And then we will have magnesium with 2 bromines or MgBr2. Yes? And I would like you guys to have a little bit of time to finish things up. So the 3 things that you are going to do are, hang on a second. If you need to redo or do any quizzes, you can do that now. I don't know why this says questions. It should say questions. 3.5a, do the questions. And then 3.4a and, 4.6a and 4.6b, that's for your test on Thursday. And I am going to go and get you guys, oh, Ravi, I have a quiz for you. Beta, I have a quiz for you. You're just in there, it's great. Thank you. Beta? This is for
Wait, you want to see the layout?
That goes up for more than one.
Right there.
Oh, yeah. This one.
This sounds good. That's
Wait, let me pull up the actual. Yeah.
so last year. No.
Let me show you where
Guys. This is such a fighter.
Did you find it? Yeah.
Previous schooling situation. They couldn't afford shoes. They walked around here like, your choice.
So are you good now? Okay, cool. Jofi, you have a question.
Last
Yeah, let me grab you one.
I kind of like desperate.
Yes.
Yes.
Where are you?
Oh, what is this? Get on my boy.
Yeah. Do I have another file? I'll have to find it for you, but I can show you your grade. You did really well.
Good job.
Yeah, it's 35. Okay, so you're, okay, I'll find it for you.
Is this 3C?
Yes.
This is the last one. Is it okay if I just do like all the C's because I want 3 quizzes?
Yeah.
Then which one I get?
Yeah.
2 times
Hi.
and 3 times.
No, that's the, there's only a B. Yeah.
But also, is my bad mark just not updated?
I forgot to put it in. Let me do it right now.